All right, number 12, a potential energy versus internuclear distance graph. It's shown for molecule A, B, and C, D. Internuclear. Okay. So when you're looking at this, I hope you are thinking about bond length and bond energy. What's the approximate bond length for CD? So you're looking at a dashed line. So we say, hey, what is the distance right here? 120 picometer. Okay, somewhere around that. We're happy. What's the bond strength of AB? We say, well, bond strength, it's right here. So it's going to be 300 and if you say 380, 385 kilojoules per mole, I would take it. Okay. And then C, is there an attractive or repulsive force between nuclei of C and D at each distance? So C and D, which means that we are looking at a dash line right here at 100 picometers apart. That means I'm looking at this point right here, 200 picometers apart. We are looking at somewhere right here. Okay. So is it attractive or repulsive force? Well, the good news is that 0 is right here. All right, 0 is right here. Anywhere below 0, you have a negative value, which means it is exothermic, right? It's exothermic because it's getting more stable. And to be more stable, it means that they are. Oh, wait, hold on. Wait, hold on. I want to make sure that I digest the wording a little bit properly. Is there an attractive or repulsive force between the nuclei of C and D at each distance? Now, the way I like to interpret this is, as long as it is below 0, it's attractive. Okay. Is this how she interpreted it? Huh? You didn't go over this? Now, the reason I make my claim is because I am wondering if she's using the peak right there as a way to distract people. Well, I mean, anywhere below 0, meaning that it's getting more stable. But it varies in degrees. So at this particular length, 120 picometer, it is the most stable configuration. So that's why we call this a bond length. But before that length, it is still attractive. It's just not the best setting yet. So that's why anything below, it's still considered overall attractive. If it is above 0, that is clearly repulsive. Okay, clearly repulsive because they don't like each other. They want to push each other away. Okay.
You said like 100 is repulsive and then 200 is attractive.
Yeah. Now, so if she's using this kind of answer, I can make this more comprehensive reasoning, and that is, well, this is the lowest point, right? Why did it go back up? It's because now there are some repulsive force, okay, to kind of negate the attraction. Yeah. Because they're too close. They're too close. But over here, they're still pretty far away from each other. So the nuclei, they're like, hey, we're not really seeing you in a close distance, so there's no repulsion. Okay, there's no repulsion when they're so far away from each other. So that's how your teacher would interpret this as repulsive, because now we are getting a little bit too close. Okay, but over there it is kind of far. So the nuclei, they don't really complain each other. There's nothing to complain.